All right, let's do another one then. Excuse me. Okay, so that's one example. Let's do another one. Okay, so let's suppose now we have a data set which consists of test scores. They're out of 10, and the scores, they're normally distributed. Normally distributed, okay? They have a mean of 6 and a standard deviation of 0.3. Okay, they have a mean of 6 and a standard deviation of 0.3. That's what they have now. Let's find the percentage of students that scored less than 6.5. So in other words, we're looking at what percentage of data values are less than 6.5. That's really what we're asking, right? Again, let me read it again. The data set consists of test scores, right? They're out of 10. We know the scores are normally distributed with a mean of 6 and a standard deviation 0.3. So we want to know what percentage of students got less than 6.5, or what percentage of data values are less than 6.5. That's what we want to know. Well, if we find the z-score, right? We want percentage of scores, so we want to get first the z-score. You know, essentially what we're going to get is the area under the graph. So we get the z-score, right? For 6.5, it's the first thing we get. All right. And what's the z-score? Well, we calculate it here, and we get 1.667. So for 6.5, right, the z-score is 1.667. Now, if you were to look in that table, again, percentage of data values, you want to think, oh, area. But now, if you looked in that table, you would not see 1.667. You would see 1.6. You would see 1.7. Well, that would tell you, though, oh, we have to round them. Right? You can see in the table here that 1.667 is not here. So what we have to do is round. And 1.667, when you round, you get 1.7. So we get 1.7. And we see that we get 0.9554. And again, this is area to the left of that z-score. This is the percentage of data values. You know, we convert to the z-score, we get the area. And then we get the area and multiply by 100, convert it to a percent. So what we get then is 0.9554. And as a percent, you know, you just multiply by 100, so we get 95.54%. That's what we get. Okay, that's pretty good. Now here's another one. Let's now find the percentage of students that scored less than 5.5. So the process is similar. We want percentage of data values, percentage of students in this case, that scored less than 5.5, right? So again, what do? We first get the z-score for 5.5. That's what this calculation is. As you can see, that's that calculation, right? So when you do that, you know, you're just subtracting the mean and dividing by the standard deviation, you get negative 1.667. Negative 1.667. That's all we get. So you would have to go back to the table. And just like with 1 point, just like with the previous part, right? Just like back here, negative 1.667 is not in the table. So if you look at the table in front of you, which is, again, I emailed it to you, it's in that PDF document it's in the textbook chapter 12 document I just emailed, you would round it to negative 1.7. And there you would get 0.0446. Let me show you. Actually, I mean, I didn't want to keep bouncing back and forth and sharing, but I guess I kind of have to, so let me do that. What am I doing now? Oh, whatever. Right, if we go to negative 1.7, right, you can see negative 1.667 is not here, so we can round to negative 1.7, and we get this, 0.0446. That's the area to the left of that. And that's what we're after. You know, area to the left, that's percentage of theta values. So we do it. Hold on. So we get area to the left, and we get 0.0446. The percentage then is about 4. So you just convert this to a percent, you get 4.46%. That's all we get. Good. Okay, so for the next one, I was going to let everyone try, but are there any questions on this? Okay. All right, so for the next one, oh, here we go. Okay, there we go. So here, what I want you to do is to do this. Just parts A and B. C we'll do together. It's a word problem from the textbook. All I'm asking you to do, okay, is we're told that the blood pressure, I think it's systolic, I think is how they, pronounce that. But blood pressure for males has an approximately normal distribution where the mean is 125 and the standard deviation is 14. So mean 125, standard deviation is 14. And what we want to know is what the blood pressure corresponds to Z values. Find the blood pressure of a man with a Z score of 0.75 and find the blood pressure of a man with a Z score of 3.2. So basically you're just doing parts A and B. That's all. Take about 5 minutes. Let me stop the recording. I'll give everyone 5 minutes for that.